Assalamualaikum and hi, my name is MUHAMAD AKBAR OSMAN bin Hashim. Today, I would like to present my recent assignment, which is assignment 2 for MMFU 5023 Advanced Manufacturing Process. In this presentation, I do require to answer two set of questions. We start with question number 1. Figure 1 shows a set of metal products machined by a non-conventional machining process. We do have four questions related on this figure and how it's made by the non-conventional machining process. Okay, let's start to answer question 1.1. Suggest the most suitable process to fabricate the metal product. Refer to figure number 1. Based on my experience and what I'm studying, the best or the suitable process to fabricate this kind of product is based on laser cutting or laser beam machining, LBM. Based on the thin sheet structure, integrate repeated profile, and clean cut edges, the laser beam machining is the most suitable non-conventional machining process to perform cutting on this kind of metal sheet. Hereby, I also attach a video showing on how the laser beam machining will cutting on the metal sheet. Okay, we go for next questions. Now we add question 1.2. Justify your solution in 1.1. The metal products shown in Figure 1 are more suitable fabricated using laser cutting due to the following reasons. Reason number 1, high precision and dimensional accuracy. Reason number 2, excellent edge quality. Reason number 3, non-contact machining process. And reason number 4, high productivity and repeatability. Let's continue with question 1.3. Describe the working principle of process selected in 1.1. We did select laser beam machining in question 1.1. The working principle of laser beam machining is explained as it is. Laser cutting operates based on the use of high energy focused laser beam as a heat source. The laser beam is generated and directed through optical lens to a very small focal spot on the metal surface. Then, at this focal point, the intense energy density causes the metal to melt and or vaporize. An acid gas such as oxygen or nitrogen is then used to blow away the molten material from the cutting zone. By moving the laser beam relative to the workpiece using CNC control, precise and complex cutting profile can be produced. This is the working principle of this laser beam machining. Equation number 1.4. Discuss three significant process parameters that can affect the process selected in 1.1. The three significant process parameters to laser beam machining are: number 1, laser power. Laser power will determine the penetration level to the part. Number 2, cutting speed. Cutting speed will determine cutting quality. And the last, number 3, acid gas time and pressure. The appropriate gas time and pressure will determine the cutting efficiency and as well the cutting quality. So now we answer all the four questions under question number 1. Let's go for question number 2. Question number 2. Question number 2, we have one table, the table 1, process parameter for laser welding process. This table lists two sets of laser welding parameters between stainless steel and low carbon steels. We do have three questions related on this equation to be answered. Question 2.1. If the laser welding was conducted on two instead of stainless steel and low carbon steel material, which are same size, suggest which side of parameters will give higher depth of penetration, given the information in the table 1 related to stainless steel and low carbon steel. To determine which set of parameters will give high depth of penetration, we need to determine the net heat available of welding, which is HW. A higher net available for welding HW result in a great weld penetration depth. To determine the HW, we need to understand the H, the heat input per unit length. The formula H equal to laser power over the V, V the cutting speed or velocity. We also know that the laser power is IV. So the formula becomes H equal to IV over V. And we do also understand that the IV equal to P. Therefore, the equation for H is changed to H equal to P over the V. V is the cutting speed. To understand the HW, net heat available for welding, the formula will be H times F1, the transfer efficiency, times with F2, the melting efficiency. So the equation will be net heat available for welding HW in bracket P over V times F1 times F2. Continue with the question 2.1. We start to calculate the HW for the stainless steel set. Given P equal to 3500 watt and the V, the speed is 100 mm per minute, and we need to convert to mm per second, will be 1.667. The F1, the transfer efficiency in the table is 70%, which is 0.7, and while the melting efficiency is 0.7. First, we need to understand on the value of P over V, the raw heat divided by length. So 3500 divided by 1.667 equal to 2099.58 joule per mm. The net heat available is 2099.58 times 0.7 times 0.7, and the available heat is 1028.79 joule per mm. We continue the calculation to low cover steel that the P given is 3000 watt. The velocity or the speed is 200 mm per minute. When we convert to mm per second, we become 3.333 mm per second. The F1 transfer efficiency percentage in the table is 50%, which is 0.5, and F2, the melting efficiency, is 0.9. The raw heat over the length, so 3000 divided by 3.333, so equal to 900.09 joule per mm. The net heat available for low carbon steel set, we need to calculate by 900.09 times 0.5 times 0.9, and the answer is 405.04 joule per mm. Therefore, based on the calculation, the stainless steel parameter set provide deeper penetration, which is 1028.79 joule per mm. Question 2.2. If the stainless steel workpiece was to be welded with Nd:YAG laser and excimer laser, specify which joint will give higher depth of penetration. Following are my answers. Nd:YAG laser operate at longer wavelength, which is at 1064 nanometer, and are capable of delivering high power density suitable for keyhole laser welding, which enable deep penetration in metals. In contrast, excimer laser operate in the ultraviolet range in between 193 to 351 nanometer and are primarily used for surface processing and micromachining, where penetration depth is shallow. Hence, Nd:YAG laser welding result in deeper weld penetration. Nd:YAG lasers are best suitable for thermal cutting of metal and thick material, while excimer laser provide ultra-precise full cutting for thin and brittle material with minimal thermal damage. Continue my answer for question 2.2. The table will show how the fundamental characteristic of Nd:YAG and excimer laser. The first aspect, wavelength. The wavelength for Nd:YAG laser is 1064 nanometer, while the excimer laser cutting is at 193 to 351 nanometer. Material suitability for Nd:YAG is metal or thicker materials, while excimer laser cutting mostly for polymer cutting, ceramic, glass, and semiconductor cutting. The third aspect is cut thickness capability, NDX suitable for thicker section, while excimer laser cutting best for the thin material. And the last, typical application for NDX normally doing cutting for metal cutting, welding, and also drilling, while the excimer laser cutting is more on micro machining, medical device, and also electronics. Now we at the final question number 2, question number 2.3. Discuss 3 reasons why water-jet machining WJM can be an interesting non-traditional manufacturing process of ceramic industry. Water-jet machining WJM presents several advantages for ceramic manufacturing. The reason number 1, no heat affected zone. WJM is cold cutting process, preventing thermal cracking and phase change in brittle ceramic materials. The reason number 2, low mechanical cutting force. Minimal cutting force reduces risk of fracture and chipping, common issue in the machining ceramic. The last reason, capability to machine hard material. WJM water jet machining effectively cuts compact shape in hard and brittle material like ceramic without significant damage. I'm complete. Present and answer all 2 sets of questions. Thank you very much for listening my presentation. Take care. Bye.